Hey guys, Mrs. Stans here. So we're on lesson 8. We're finally starting our word problems with equations and inequalities. So if you could turn to lesson 8 and write down the objective on the lines provided, we will create equations and inequalities in one variable and use them to solve problems related to geometry. You should check your homework answers from lesson 7 if you haven't already done so, and you should be working on a do now. But I will go over the do now with you. So in order to write equations from word problems related to geometry, you do need to know what certain shapes are. So an isosceles triangle, we typically draw like this, and we put marks on the sides. When marks are the same on sides, it represents those sides being congruent. Congruent means equal in length. So an isosceles triangle is a triangle with at least two congruent sides. A scalene triangle is a triangle with no equal sides. So maybe something like this. So I don't have to mark it at all, or I could put different marks on all three sides, showing that I don't want any of the sides to be equal. An equilateral triangle is a triangle with three congruent sides. Remember, congruent means equal in length. A rectangle is a parallelogram with opposite sides parallel and congruent. A square actually is a rectangle. It's just a special rectangle. Instead of just opposite sides congruent, all four sides are congruent. Also, a rectangle and a square has right angles. A hexagon has 6 sides. If we just call it a hexagon, it doesn't mean that any of the sides are congruent. If we call it a regular hexagon, it means all the sides are congruent. But really, just a hexagon means has 6 sides. So there's a few problems we're going to work on together. We'll do number 1. The length of the second side of a triangle is 2 inches less than the length of the first side. So let's stop reading there. Let's draw a triangle. I'm just drawing any old triangle. It doesn't really tell me much about it. I'll call this the first side, this the second side, and this the third side. So if the second side is 2 inches less than the length of the first side, it's the first side that I should call X. So when you draw a diagram, it takes the place of let statements. You don't have to say let x equal the first side. You can just do a drawing and label it. And remember, the second side is 2 inches less than the length of the first side. So that would be x minus 2. Now we continue reading, and it says that the length of the third side is 12 inches more than the length of the first side. 12 inches more than means to add on 12. And here we have our sides labeled. Perimeter, remember, means add up both sides, and it says that the perimeter of the triangle is 73. So if I add the first side to the second side to the third side, I should get 73. And now this is an equation to solve. If I combine like terms, I get 3x plus 10 equals 73. Subtract 10 from both sides and divide both sides by 3. I get x is 21. I have to go back to my let statements so that I could label the sides properly. So my first side is 21. My second side is 21 minus 2, which is 19. And then my third side is 21 plus 12, which is 33. So the sides are 21, 19, and 33 inches. We will move on to number 2. Two sides of a triangle are equal in length. What was that called again? Isosceles, yes. The length of the third side, so I guess this will probably be the first, second, and third. I wish they would have called it the base. The two sides of an isosceles triangle that are equal, we typically call them the legs. And then that third side that's not congruent to the other two, we usually call it the base. But it says that the length of the third side exceeds the length of one of the other sides by 3 centimeters. So I don't know one of the other sides, so I'll call it x. It is isosceles, so this one's also x. But the third side exceeds, means it's bigger than, the length of one of the other sides by 3 centimeters. So let's add on 3 to one of those legs. Again, they're talking about perimeter, so let's add up the first side to the second side to the third side to get 93. And we'll combine like terms and solve. I'll subtract 3 from both sides, and I'll divide both sides by 3. I get that x is 30. So if I go back to my drawing, one of the legs is 30, the other leg is 30, and then 30 plus 3, the base would be 33. It says find the length of each of the shorter sides. The shorter sides are 30 centimeters each. Let's do number 3. The length of a rectangle. So let's draw a rectangle. It has opposite sides congruent and parallel, and it has 4 right angles. The length, when they talk about the length, they're usually talking about the longer side. This typically we call the width, while this we typically call the length. So the length of a rectangle is 5 meters more than 6 times its width. So I don't know what the width is, but it says that the length is 5 meters more than, so it means I'm adding on 5 to 6 times the width, to 6x. The order that we write this is important. It should say 6x plus 5. 5 gets added on to 6 times the width. And talking about perimeter again, is at most, oh, this is why I chose this question, at most 66. That's an inequality. If it's at most 66, the most it can be is 66, meaning it could be 66 or less, right? So perimeter means add up the sides. Don't forget that there are 4 sides, so you might want to go label the others. And if I add all 4 sides, the order in which you add them doesn't matter. But that expression represents the perimeter. The perimeter is at most 66. So it might be less than, but it could also be equal to 66. And it says find the largest possible dimensions of the rectangle. So let's solve this. Combine like terms. That's 14x plus 10 is less than or equal to 66. Subtract 10 from both sides. And divide both sides by 14. X is less than or equal to 4. So they're asking for the largest possible dimension. So the largest x could be is 4, right? X might be less than 4. So we're going to use 4 when we go back and label it. So 4 is the largest width, and 6 times 4 plus 5, 29, is the largest length. When they are asking for dimensions, they're asking for both length and width. So the largest dimensions are 4 meters by 29 meters. And now I'm going to skip to number 8. I really like this question a lot, actually. So a triangle and a rectangle have the same perimeter. So I'm just going to make myself a note. I want to do triangle perimeter equal to rectangle perimeter. Like that's how my equation is going to be. The triangle is a scalene triangle. So it has 3 sides that are different, with the second side measuring 2 centimeters bigger than the first. So I'll call this the first, I'll call this the second, I'll call this the third. The second side measures 2 centimeters bigger than the first. So I'll let my first be x, I'll let my second be x plus 2. And the third side is 1 centimeter larger than the first. So the third is x plus 1. The rectangle's length is equal to the triangle's first side. So I'll call the length x, because that's what I called the first side. And then the rectangle's width is 1 centimeter less than its length. So that means I subtract away 1. And I have this little note here that was very important. When I write the equation, I want to do the perimeter of the triangle equal to the perimeter of the rectangle. So remember, to find perimeter means add up all the sides. So for the triangle, the first side plus the second side, oh, the second side had a 2 here, plus the third side equals the 4 sides of the rectangle. And this is the equation that we have to solve. So on the left side, I'll combine like terms. So I get 3x plus 3. On the right side, I'll combine like terms. I get 4x minus 2. I'm going to subtract 3x from both sides. I'm going to add 2 to both sides, and I get that x equals 5. So find the dimensions of each figure and find the perimeter of each figure. All right, so in place of x, I'll put a 5, so the first side of the triangle is 5. The second side is 5 plus 2, which is 7. And then the third side is 5 plus 1, which is 6. So that perimeter would be 18. And what are these units? Centimeters. And then if we look at the rectangle, the lengths would be 5, the widths would be 4, and 10, 18. Perfect. The perimeter is 18. See, by me doing the perimeters of both, I know that I didn't make a mistake because they did turn out to be the same. I'm going to skip to number 10, and this is the last one I'm doing with you. So the side of the square is 10 meters more than the sides of an equilateral triangle. So square has 4 equal sides, and an equilateral triangle has 3 equal sides. The side of a square is 10 meters more than the side of an equilateral triangle. So I don't know the sides of the equilateral triangle, so I'll call them x, and the side of the square is 10 meters more than, so x plus 10 on each of the sides. The perimeter of the square is 3 times the perimeter of the triangle. So let's think about this. The perimeter of the square is 3 times the perimeter of the triangle. I made like a little note for myself. Perimeter of the square is, so I put an equal sign, 3 times the perimeter of the triangle. So let me do it. The square is x plus 10 plus x plus 10 plus x plus 10 plus x plus 10. I hope you agree with me that I could just do x plus 10 times 4 instead of writing x plus 10 plus x plus 10 plus x plus 10 plus x plus 10. So I'm going to write it like this and do the distributive property. And then I have to do 3 times the perimeter of the triangle, x plus x plus x. So it's 3 times 3x, which is a 9x. So I have 4x plus 40 equals 9x. I'm going to subtract 4x from both sides. I'll divide both sides by 5. And x equals 8. Find the length of each side of the triangle. So all we want is the triangle. The triangle is labeled x. So each side of the triangle is 8 meters. So you can see that when we're doing word problems with geometry, you should draw your picture. You should label it according to the wording in the problem. And then after you label it, you'll make an equation. After you solve your equation, you go back to your diagram and you fill in what you found for x, and you'll find the missing sides of any of the figures that you did. You have to make sure you are answering the question being asked, so always go back and read usually that last sentence to make sure you're answering the question that they're asking. So I hope this was good, and I'll see you soon. See ya. Bye.